Hello students. So today we will be talking about the ray optics. It is lesson number I think 10 in your CBSE, and it's a very important component of the question paper. Lot of questions will come out of this. This topic is very good but very easy, which you can easily understand, and once you understand you can easily have a very good output out of it. Now, ray optics is nothing but it talks about the study of light. Now, if we talk about the spectrum, as you see on this picture, on this slide, you will see basically we have gamma rays, X-rays, ultraviolet rays, light, and then infrared rays, MW and RW radio waves as well. Now, in this whole spectrum, it is only this portion which is visible to us, okay? And this portion basically between this range is actually visible. So ray optics is nothing but when we talk about only of this portion of the spectrum. Also, you have to understand, as I have drawn it here, this optics, let me put it, this optics can be broken into two portions, ray optics and wave optics. Now, ray optics is nothing wherein we deal with dimension of objects like mirror, lenses, prism, right? Much larger than the wavelength of light. Okay. Now, wave optics on the other hand is dimension of object are comparable to wavelength of light, like slit, holes, interference, diffraction, polarization, etc. Okay, so let me summarize it, whatever I have covered up till now. See, ray optics is nothing but study of light, and in the spectrum, in the broad spectrum, if you see, you have gamma rays, X-rays, UV rays, light, which will study and which is a component of VIBGYOR, then infrared rays, MW radio waves. This is the broad spectrum, but in ray optics we will study only this portion, light, let's say, and the range is from here to here, and this composes of two things, ray optics and wave optics. Ray optics is also sometimes called as geometrical optics. Okay, now here dimension of objects are much larger than wavelength of light, like mirror, lenses, prism, telescope, etc. Okay. Now, coming on to wave optics, dimension of objects are comparable to wavelength of light. Like here you deal with slit holes, and then you study the patterns of like interference, diffraction, polarization, and all. Okay. Also, now if we go to go further on this, I think you guys must be well aware of this, and this we have studied in 10th standard, but I am just quickly repeating for the sake of completion. Light travels in straight line, and path of light is called ray, and it is in straight line, right? And bundle of rays is nothing but bundle of rays is beam. Okay, let me make it more visible. Yes. Now let's talk about the reflection. So in the case of reflection, one thing we have to remember is, if this is the incident ray, then this is the reflected ray, right? This is R. Okay. Now in this case, remember I would be equal to R. These are the laws of reflection, and incident ray, reflected ray, and normal. This is normal. This is at 90 degree. These lie in the same plane at point of incidence. Okay, this needs to be remembered, right? Now, if if the ray is something like this, let's say this is the surface and the ray is coming in the path of the normal itself, then it will return here also. So if it is coming this way, then it will return in the same path. Okay, so in this case, angle I is equal to 0 and angle R is equal to 0. Okay, and now if it is, let's say if you have a polished sphere like this, you have a polished sphere which is polished from inside. Now in this case, remember, if this is the center of sphere, and the normal shall always pass through the center of sphere. So basically, if let's say incidence ray is coming this way and we have to draw the normal, then you have to draw the normal in the line of, it will be this. Okay, so this would be normal, because it should, when you extend the normal, it should pass through the center of sphere. Now this is what, this is incident ray. So the reflected ray would be somewhere here, let's say somewhere here. This would be right. Okay, and angle, this is the angle I and this is angle R. So again I will be equal to R. So if I have to write, normal should pass through center of sphere. Okay, now if I is equal to R, then again you can say the same thing. If if this is, let's say, the path and I is coming here, incident ray is here, then the reflected ray will also be in the opposite direction. Okay, and in this case angle I is equal to angle R is equal to 0. Okay, very good.